I'm Kate Leroux, and this is my partner Jane Park, and we are GIS certificate students at UW in Seattle. This project is our capstone project for the program, and we've spent almost 2 quarters on it. What happens is that our instructors solicit projects from organizations in the community, and they submit proposals, and then the students choose which projects they want to work on in small groups. So Jane will be telling you a little bit about the Washington Poison Center, our sponsor, and then I'll return to talk about our project.
So I'll tell you a little bit about the Poison Center, Washington Poison Center, and the good work they do, our project and the work we're doing, and how the work we have done so far is already making a difference. So here's the team of the Washington Poison Center. They have their office in the Northgate area of the city of Seattle. And what they do is they provide immediate, free, and expert help over the phone to anyone calling in if they've had exposure to hazardous materials or poisons, toxic substances. Their calls are answered by professionals, nurses, pharmacists, poison experts, and they serve the whole state of Washington, including hospitals that will call in to get assistance. They answer over 60,000 calls per year. Does anyone want to take a guess as to what the #1 call is? It's children under 5 swallowing a foreign object like a toy. So over 50% of their calls concern a child 0 to 5 years old. They save the public about $12 million per year in avoided unnecessary hospital visits. 60% of callers would have visited the ER or called 911 and incurred a big bill and wait time that nobody wants to go through waiting for ER care. The problem they're facing is that government funding could disappear. They are heavily reliant on state and federal funding. 87% of their funding comes from those kinds of sources, and they also rely heavily on CHIP funding, which needs to be re-upped every 2 years and is not a for sure thing. So they needed to create new ways of generating revenue. How can GIS help? Well, they had no GIS before. This is an example of what they had. As you can see, the map is not very pretty or persuasive or clear, and we knew that we could provide better spatial analysis and cartography. Okay. So they have this rich set of call data from people calling in, but it's all trapped in this database in tabular format, and they don't have a way of visualizing it geographically. So we sat down with them to find out what they needed and what their priorities were to do with their data. Primarily, the first most important thing is to demonstrate how they are at the center of poison and toxic substances. They have knowledge and expertise, and there's a strong need for what they do. This is so that they can present that to potential funding sources, because maps can be a powerful marketing tool. So once that's taken care of, they also have some other things they would like. They want to be able to use maps to improve their own understanding of their data. And this is, we're setting them on the path for GIS, and they'll take it from here and run with it after we're done with the project. So for our project, as students, we had a problem because we started it before we had learned everything we would need to do by the end. So we wanted to make sure that we gave them concrete deliverables. So how do we structure our project? Well, we made it into 3 complete and discrete phases. So each phase has its own planning and its own execution, and then deliverable at the end. And then in between each phase, we can revisit priorities, see if anything's changed. Now I'll tell you a bit more about each phase of our project and what we did. So in phase 1, we got a one-time data export of 3 years of call data, 2012 through 2014. This was like about 180,000 records. Then we did a lot of sort of data slicing and dicing. We ended up with over 100 data tables because we had to create one for each map. The Poison Center had certain substances they wanted to focus on, and certain age groups, and certain kind of boundary areas, which I'll talk about in a minute. We decided to use, for classification, Jenks natural breaks classification because it's unbiased and could be applied equally to all of the maps. So then after we did all the sort of data transformation, we brought it into ArcGIS. And that's where Jane did most of the data crunching. And then when I got it,
The data is at a zip code level and a county level, but the Poison Center sometimes wants to map by things like legislative district or hospital council area. So we had to do some geoprocessing to get the sums for those larger areas. So I built a bunch of things in Model Builder to pass the data through. We unioned the zip code with the larger area like legislative district and then dissolved it into the legislative district. One important note there is that I had to make sure that it was set when a zip code was split between boundaries, that the call value was divided by the ratio of the area and not duplicated between areas. And then after that, there was a cartography phase. I had a checklist to walk me through all of the steps there so I would be consistent, because we did create 73 maps. So I'll just quickly show you my model. There we go. This is the main important one, is the bigger one here, that takes the data from zip codes and sums it into these larger areas. But I used some other ones as well. So let's take a look at some of the static maps that we created. This one shows calls about e-cigarettes for all ages in the year 2014. This map is normalized by population, so it's per million people. Some maps were normalized and some were not. They sometimes wanted both, depending on the audience. You'll see there's a lot of green in our presentation. We took the Mr. Yup green, that's their sort of flagship color. I made that the middle of the color ramp so that all the maps would fit their color scheme. Let's see. So yes, I had this checklist as I did the cartography, so that I would make sure that I didn't miss any steps through the classification and the symbolization, updating the legend, label expressions, and then at the end, for each map, I converted the labels to graphics and manually tweaked their placement. Here's a second map. This one's showing marijuana cases in 2014 for just pediatric patrons, so only under 18. This is one by legislative district, so it's one of the ones that went through those models that you saw. Legislative districts are divided by population, and so the Puget Sound is just way too cluttered to show on this map, so I had to make it inset. So the legislative maps were 2 pages. Here's the second page of the same map. So this is helpful when you're showing it to the legislature, and each representative wants to see how their own district is doing first, of course. Okay, one more map. This one is one of the few that we made showing the data actually at the zip code level. This is just Snohomish, King, and Pierce County, showing prescription painkiller calls in 2014. This one's not normalized, so it's just straight call totals. I have plenty more to say about the cartography, so if anybody's interested, you can talk to me afterwards. We also have all of the maps here in this book, if anybody wants to flip through and see more of them. We have a couple of those up here. So that was phase 1, which took a while. So phase 2 was designed as kind of a quick follow-on. We took the maps and the data that we'd already created and brought them digital, made them digital. We created some animated time-lapse maps and an ArcGIS online map within a web app. So I'll show you that. First, I'm going to show you a time-lapse map. This is showing the progression of all calls through 2014, and it will be cumulative, so each month the numbers will grow. The challenge with this map was formatting the data in a way that the time-lapse would work, because we had time values for each county, but the way the time-lapse feature in ArcGIS works is that you need to have it transposed so that each row only has one time value. So we after some research, we found 2 different ways to do that. The Make Table Query tool and also the Transpose tool will do that. Here's our ArcGIS online map. So in the center there, the state is the web map, and then around it is the web app. The web app is using the summary viewers template from ArcGIS Online, although it's actually, we put it on our own server and made a few little modifications to it. But it shows exposures and then the totals for each substance category. And there's lots of pages. You can click through the pages. You can also click on a county to see the values for that county. You can also click on the names to see a definition if you're not sure what they all are. ArcGIS Online has a lot of benefits. It's interactive. It's easier for people to edit, and it's sort of, you know, fun because you can zoom around. But it has some drawbacks. The functionality is pretty limited, and the cartography suffers a lot. I wasn't even able to use the right green color because the color palettes are limited. And that brings us to the current day. We've just finished phase 2, and we're embarking on phase 3 for the rest of the quarter. And so what we would like to do is first some data automation. Right now we've been working with that single one-time data export, which ends at the end of 2014. And ideally it would be great if we had a regular export from their system into a geodatabase, so we could do things like create a dashboard for their call center, which is something they're excited about having. And then also maybe some kind of online map that has more features and is a little more customized than the one that we were able to create so far. So we're doing the research for this right now. If anyone in the room has information about data automation in particular, I'd love to talk to you about that. And then at the end, of course, we're going to do a handoff. We're going to put some effort into really documenting what we've done, handing it off, making sure it's all running on their system so that they can continue after we're done. So we learned a few things. Keeping your files and tables organized is especially important when you're doing something of this scale, and doing that from the beginning with consistent naming and organizing is critical. We got all these wonderful exercises in class with a neat little data set designed just to work with that feature that we were learning. And in the real world, obviously, data doesn't work like that, and so it takes time to transform your data into the form that you need and clean it up, that kind of thing. And finally, it always takes longer than you think. We underestimated the amount of time both the spatial analysis and the cartography would take in phase 1, so we had to redo our schedule after that. But we also found some more amusing things in the data as we were looking through it. There is a substance category called weapons of mass destruction. So we were curious, well, what is that? What are they putting under this category? There were a few things like anthrax and white powders, but then there were also a lot of other things that were typed in under that category.
White rabbit.
Weapons of mass destruction is the last in the list alphabetically, so I suspect that maybe sometimes it was picked by mistake. So I'm going to spend my last few slides talking about how our work is already being put to use by the Poison Center. One of the most rewarding things about this project is that as soon as they got our maps in hand, they started using them and have said that they've been getting a great response. Just in the past month, they've presented our maps to a lot of people, and this is just some of them here. They create a quarterly toxic trends report, which is a little one-pager on something newsworthy. The most recent one there is on the top of the stack, and there's our map in the middle. That one's on marijuana, and we have lots of copies of that. If anyone wants to take a closer look and take it with you, you can. They also just completed their 2014 annual report. There's our map on page 4. This is more important than usual this year because they are making a proposal to cover calls for the entire state of Wyoming, in addition to Washington. So our maps are playing a part in their proposal to try to grow their business, which is exciting. Throughout the project, we've really put an emphasis on our relationship with our sponsor, tried to be responsive to their needs and priorities and preferences. And so I'm just going to close by letting them tell you in their own words some of the impact that our work has been having on them. That's Dr. Garrard testifying in front of the legislative committee. And then one more slide. This is the executive director here. She's the one. And that's it. If you don't have this number programmed into your phone, you should, in case you or someone around you is having an emergency that is poison or toxic related. In Oregon, it's the same phone number, although you will get the Oregon Poison Center instead of the Washington one. And there's our name and information. Does anyone have any questions? Yeah.
So I was noticing in the maps that the water bodies weren't clipped in
describe why you chose to do that?
Yeah, the state of Washington is an important sort of visual aspect for the Poison Center, and they really like the bodies of water. So we included the Columbia River on top, and Puget Sound when I didn't have data value for the counties there. I played with it a lot, but I didn't find a way to include the boundaries of Puget Sound when I needed to show a color on the choropleth map. It just was too busy.
I think this is a good example what GIS actually can do for the public awareness and also for the decision-making processes.
Yes.
And that's what we need actually to continue doing a lot of that, not just in particular in this area, but in any area and different disciplines.
Yeah, in
Very
fact,
good job.
thank you. The state legislature is currently considering regulation for e-cigarettes, and the Poison Center is down there testifying and being part of that process. And now GIS is part of it too. Any other questions? Yeah.
I was just curious because I heard you talking about in your core custom maps, right? You're saying that sometimes you normalize population data, but sometimes you did not, based off per their request.
Yeah.
Are you worried that maybe that somehow they would that's like a manipulated findings? If that's going to be like a problem? I get for marketing purposes. I mean, the maps can tell major stories and really fast relay information. I just wasn't sure if that was something you were worried like that it would be somehow less factual, the representation.
Yes, we were worried about that. Some initial conversations with our sponsor about how things should be displayed kind of set my mind at ease because they really seem to be, have a scientific approach and want to be as accurate as possible. So after talking to them, I was less worried that they would use this to distort the numbers. So the map that shows just totals for the state is designed to show for people out of state where the population is, really, because the two most populated counties are the ones with the highest numbers. So if for people within the state, the normalized ones are more interesting, like what areas are proportionally different. But for out of state, if you don't know it, it just shows sort of hot spots in what the state looks like population-wise.
I think it's a great project too, just by the way.
Thank you.
Thank you.
Anything else?
All right, we don't have any more questions. We are still missing one of our presenters. So